You are sitting in a leadership meeting, hearing the same promise again and again: faster delivery, better quality, fewer bugs, and happier developers because your teams are using GitHub Copilot inside GitHub Codespaces. It sounds like a productivity win you cannot ignore. And for a while, it is. Pull requests move faster, prototypes appear overnight, and the backlog starts to shrink. Then you learn something uncomfortable. The same convenience can also become a silent takeover path, where a poisoned GitHub issue steers a Copilot agent, leaks a privileged token, and escalates into repository control without the attacker ever speaking to your developers. The most important part is this: you do not need to be doing something wrong for this to matter. You only need to be doing something normal. Now that the risk feels real, you can see the deeper issue. An artificial intelligence coding assistant is not just autocomplete. It is a decision influencing component that reads context, follows instructions, and can shape actions inside an environment where real credentials and real source code exist. Traditional security assumes clear boundaries: untrusted internet outside, trusted systems inside. But with an assistant in the middle, the boundary shifts. Untrusted text can arrive as an issue, comment, documentation snippet, or logline, and the assistant can treat that text as guidance. That is the essence of prompt injection, and it forces you to protect the interpretation layer, not only the systems. With that new trust boundary in mind, imagine how ordinary this starts. Somebody opens a GitHub issue that looks like a normal bug report or feature request. Nothing suspicious. Then a developer does what modern workflows encourage: launch a GitHub Codespace from the issue context to reproduce the bug quickly. In the public descriptions of RoguePilot, the critical coupling is that the issue content can be passed into Copilot's working context automatically. That means the attacker does not need a conversation. They only need their text to be present at the moment the environment spins up, turning a normal workflow step into a trigger. Once you accept that the assistant can ingest issue text as context, the attacker's next move becomes obvious: hide malicious instructions where humans will not notice them. Modern markup can conceal content from a casual reader while still leaving it present in the text stream the assistant processes. So your developer sees a clean issue, but the assistant sees the hidden payload. This creates a new kind of social engineering, where the target is not the person. The target is the tool the person trusts. Now that the attacker can influence the assistant's behavior, the goal shifts from confusion to control. You might assume the assistant only suggests code, but agent-like behavior lives in a workspace full of files, settings, and tokens. Public reporting on this class of weakness describes the high-impact outcome: exfiltration of a privileged GitHub token from the Codespaces environment, enabling repository takeover actions depending on token scope. The pattern behind the headline is the real lesson. A high-trust credential becomes reachable from low-trust content. Even if vendors patch a specific weakness, you still need to treat this as a durable risk pattern. This is what it looks like when artificial intelligence becomes part of the software supply chain. You already worry about dependencies, build systems, and signing keys. Now you also worry about assistants, agents, and the content they ingest. The question for you as a leader is not whether one exploit lands tomorrow. The question is whether your architecture assumes that adversarial input can reach the assistant in normal collaboration workflows. At this point, it is tempting to focus on developer behavior, but that is not where the most value is. In stories like this, the developer follows the intended workflow. Open issue, open code space, move fast. The risk comes from defaults that optimize convenience over adversarial thinking. As a leader, your responsibility is not to slow down delivery. Your responsibility is to remove unsafe assumptions from the system of work, so productivity does not come with invisible compromise paths. To design better controls, you need a clean mental model. Many large language model systems do not separate instructions from data. Both arrive as text. That means attackers can bury directives inside content that looks informational. When the assistant is embedded in a developer environment, those directives can influence what gets opened, what gets pasted, what gets summarized, what gets committed, and what gets revealed. That is why you must treat agentic assistants as part of your control plane, not merely a user interface enhancement. Now bring this into an enterprise context you recognize. You maintain a public-facing repository or even an internal repository that still allows broad participation. Someone submits an issue that appears helpful. A developer opens a code space from that issue to reproduce a bug. The assistant is seeded with the issue text. Hidden instructions nudge it to helpfully collect context or to output something that inadvertently exposes sensitive material. The details vary, but the shape remains constant. Untrusted collaboration content influences a trusted assistant inside a privileged environment. With that scenario in mind, you can see why this is not a one-off. As assistants become more autonomous and more connected to tools, attackers will treat them like a new attack surface. They will test what the assistant can read, what it can infer, and what it can cause a user to do. So your architecture must assume that assistant misuse will increase as capability increases, and you must design for a world where language-driven systems are routinely manipulated by adversarial inputs. So instead of reacting tactically, you step back and redesign. You treat the assistant and its workspace as a new tier in your secure development architecture with its own threat model. In that threat model, you assume the assistant will ingest untrusted text. You assume attackers will attempt indirect prompt injection. You assume outputs can drive downstream actions. And you assume tokens in the environment are a primary target. This is not fear. This is modern architecture discipline. Once you adopt an architectural view, governance becomes straightforward. You define where agent-like workflows are allowed and where they are restricted based on trust. In low-trust zones such as public repositories and community issues, you reduce automation, restrict context seeding, and limit token privileges. In high-trust zones, such as tightly controlled internal repositories, you allow more convenience but still keep monitoring and identity controls. Governance is not banning the tool. Governance is matching capability to trust. Now you focus on what attackers really want: credentials. This story should trigger a design review of token scope, lifetime, rotation, and the business impact if a token is exposed. You push toward narrow scopes, short-lived tokens, and least privilege aligned to the actual task. You remove long-lived broad tokens from developer-like environments wherever possible. Even when you cannot eliminate credentials, you can shrink the blast radius so a leak is painful, not catastrophic. With identity tightened, you reinforce containment. A secure architecture assumes developer environments can be abused, so you design them like semi-hostile zones. You limit what a workspace can access by default. You reduce lateral movement paths, and you enforce boundaries so the workspace can do its job without becoming a warehouse of secrets. The goal is not to distrust developers. The goal is to ensure that a compromised workflow stays content. Now that your controls are in place, you need visibility that proves they work. You want enough telemetry to answer practical questions. What seeded the assistant context? What actions were suggested? What files were accessed? Whether outbound activity looked unusual? And whether token usage spiked in suspicious ways right after issue-driven sessions. You are not chasing perfect monitoring. You are building fast detection and confident investigation so the organization can respond without guesswork. With observability supporting you, you can brief executives clearly. You explain that artificial intelligence assisted development improves delivery, but it also introduces a new trust boundary where untrusted collaboration content can influence an assistant inside environments containing intellectual property and credentials. Your strategy is not to remove productivity tooling. Your strategy is to professionalize it with governance, isolation, and identity controls, just like you already do for pipelines, secrets, and production access. That frames the discussion as risk management, not fear of innovation. To keep decisions consistent, you anchor on a simple framework. Capability is what the assistant can do in a given environment. Context is what untrusted content it can ingest automatically. Consequence is what happens if something leaks or is misused. When you evaluate Copilot and Codespaces deployments through these three lenses, you avoid blanket rules and instead apply tiered controls that fit the real risk. Let's now discuss the key takeaways from what you learned so far. You have seen how a normal GitHub issue can become a trigger when its content is automatically fed into an assistant's context, enabling passive prompt injection and creating a pathway toward credential exposure and repository compromise. You have also learned why this is bigger than one vulnerability. It is a repeatable risk pattern that emerges whenever language-driven assistants operate near privileged tokens and sensitive code. And most importantly, you now have a leader-friendly response strategy. Redesign trust boundaries, apply governance by trust tier, reduce credential blast radius, enforce workspace containment, and build observability that catches misuse early. Subscribe to the channel for more leader-focused cybersecurity stories like this. Like this video so it reaches more security leaders and enterprise architects, and share it with your development and platform teams, and comment below with how your organization is using artificial intelligence coding assistance right now. Whether you are going full speed, cautiously piloting, or still deciding, because your input will help shape what I cover next.